Hi, this is BRR. We'll discuss about some more in detail about SSL certification or HTTPS request in this session. In the earlier session, we discussed what is HTTPS request and what are all the advantages of using this HTTPS protocol and padding to your requests when you send requests to the web server. So, if you look at this, HTTPS request, how it is being, generating request with the SSL certificate and processing your request to the web server. Basically, this secure socket layer. So what we discussed, this is certificate which is being involved when you when this SSL, HTTPS request is encrypting your data before sending to the web server and before sending the response from the web server. Again, web server is encrypting this SSL, the certificate as encrypted data and sending to the client. So basically, SSL fundamentally works with following concepts. Asymmetric cryptography and asymmetric cryptography. They are using these two algorithms when the request is processing using HTTPS protocol. Asymmetric cryptography is nothing but this is also known as asymmetric encryption or public key cryptography process, which uses mathematical related key pair to encrypt and decrypt data in the request. In the key pair, one key is shared with anyone who is interested in a communication, and this is called public key. And other key in the key pair is placing as a secret, and it is called as private key. So basically, it is using two keys, public key and private key, in this the asymmetric cryptography algorithm. So public key is basically shares the information to anyone who is interested in communication, and when it comes to public private key, it is placing as a secret because completely private key. So it only available for the concerned request holder, not for all the people who are interested in the communication. Here the keys refer to a mathematical value, and where everything were created using mathematical algorithm which encrypts and decrypts the data. So let us say, like, if you send some user authentication request, let us say like login and password information to the web server, this username and password which you are giving on the UI will be encrypted and sending to the web server. While you sending this request from the web client, this SSL comes into the picture, and it will encrypt your data completely, basically, based on the mathematical values and mathematical algorithms which are being integrated in the SSL certificate, like asymmetric cryptography algorithms. So once the encrypted data is received by this web server, again web server will be processing your request, and it will have the response. Before sending this response, again it will follow same scenario, and it will again encrypt the data, and it will send it to the client. So in the asymmetric cryptography, the data can be assigned with a private key, which can only be decrypted using the related public key in a pair. So when the data is signed with the private key, that private key related data can be encrypted or decrypted using a public key of relevant pair in the communication. If you look at here, this request, this is what the web request. I'm sending some hello world. This is being encrypted using private key here, like come to this right side. So this is the publicly, private key being placed on the encrypted data, and it is sending through some ciphertext kind of thing. This is not structured format. So this private key can be, decrypted using a public key, and then it is decrypting, and it is sending to the response to the web server, and web server again encrypting data using a private key, and private key can be decrypted using a public key over the key pair value and sending the response back to the client. So in the symmetric cryptography, this is about asymmetric cryptography. If you look at the second one, symmetric cryptography algorithm. In the symmetric cryptography, there is only one key which encrypts data and decrypts data. Both the scenarios, sender and receiver should have this key which is only known to them. So in the symmetric cryptography, what it is happening is when the request is being sent to the web client, the web client can be encrypted data using a private key with some secret key. That key only knows to the relevant party, so who is receiving a response. So that way they will recognize your request and they will validate the key pair value, and they will decrypt the key based on that public secret key, and they will process the request, and again they will encrypt the response with using a secret key, and that secret key can be processed at the client place over SSL certificate by identifying the key value. That way, this symmetric cryptography algorithm is being processed in the SSL place. Like this, when you send the encryption key, it will send the secret key as well. And the relevant owner, the response owner, will identify the secret key, and it will decrypt the request, and it will process the response. And that process will be again, response process will be again encrypted using a secret key. This way around, vice versa, it will send you the request using this symmetric cryptography algorithm. Only the difference is, if you look at the previous asymmetric cryptography algorithm, we have a key pair value as private and public key. So when you send a request, it uses private key, and when it receives by the web server, it will identify through public key, and it will decrypt the request, and it will process the response and give you back with private key. In the client side, again, this private key can be decrypted using a public key kind of thing. So when it comes to symmetric cryptography, we have only one key, that is secret key, and that key can be shared to the relevant owner, so that it will identify easily, and it will decrypt the request, and it will process the request. SSL uses symmetric cryptography using the session key after the initial handshake is done. So the most widely used symmetric algorithms are, AES algorithms. Using those AES algorithm, we can encrypt the request data, and we can decrypt the response data very easily to bypass the hacking. So if you look at the diagram, like regarding this HTTP session key, how the data is being transferred over SSL. If you look at here, the SSL protocol uses asymmetric and symmetric cryptography to transfer data securely. The following figure will illustrate basically, like if you look at this browser, the browser will send the request using asymmetric cryptography, that is what SSL handshake. SSL handshake is nothing but communication over SSL always being with SSL handshake. This SSL handshake is an asymmetric cryptography which allows the browser to verify the web server and get the public key and establish a secure connection before the beginning of the actual data transfer to the web client. So this will send the request as asymmetric cryptography algorithm with public key and private key, and when it sends a response to the client, it uses symmetric cryptography where it has the actual data being transferred. Here it is a SSL handshake. That means browser to verify the web server, get the public key, and establish a secure connection. When it comes to data transfer, here the client the client and the server now uses a shared session key to encrypt and decrypt actual data to transfer. This is done using the same session key in both ends, so it is symmetric cryptography. So the actual data of SSL transfer uses symmetric cryptography because it is easy to take less CPU utilization consumption compared with asymmetric cryptography. Thus, SSL fundamentally works using the asymmetric cryptography and symmetric cryptography. There are certain infrastructures involved in achieving SSL communication in real life, which are called as public key infrastructure keys. So based on those keys, it will transfer data between client and web server. If you look at this public key infrastructure, it is a set of roles, policies, and procedures defined in the SSL protocol. It has some key attributes inside it, like certificate authority. This is nothing but it authenticates the identity of individuals and computers and other entities being involved in the request when you send request from the web client to the web server. And receiving a registration authority, it is nothing but a subordinate to the certificate authority that uses certificate on behalf of a root certificate authority for specific uses. And coming to the SSS certificate, the data files that includes the public key and other information, that is what the SSL certificate key attribute basically have. And fourth one is certificate management system. It's nothing but a system which stores the validates and revokes certificates which are being relevant to your request and response. These are the basic keys involved in public key. This is nothing but public key infrastructure attributes. Based on these, your request can be encrypted and decrypted on the network. So this is how the data being transferred on the HTTP and HTTP request from the client to the web server. Hope you understand the process of the data being transferred using SSL handshake and data transfer actually happening between web server and web client. Thank you. Thanks for listening to this video.